Hello, everyone. Today we're going to be covering the concept of time value of money. So, to start with, what exactly is time value of money? And I think this is best explained through an example, right? It's how you can compare the value of money across time. So, for example, let's say you have the choice of taking £100 now or taking £150 in 1 year's time. How would you choose between them? Now, initially, you might think, well, the choice is quite obvious. The 150 is clearly better than the 100, so you should be opting for the 150. But this is ignoring a crucial bit of information that's given in the problem, and that's the 1 year gap between these two streams of money, essentially. Um, to make this a bit more relatable, think about it in terms of weight. So let's say you have to choose between 10 kilograms of potatoes, let's say, or 900 grams of potatoes, and you have to choose the heavier one. You wouldn't say the 900 is bigger than the 10, and so the 900 grams would be bigger than the 10 kilograms. And that's because you understand that they are two different units. One of them is in grams, the other one is in kilograms. So what you could do, for instance, is to convert them both into kilograms. So you can convert the 900 grams into 0.90 kilograms, and then now, because they're in the same unit, you can compare them and say, well, the 10 is bigger than the 0.9, and so the 10 kilograms must be bigger than the 900 grams. Alternatively, you could also convert them both into grams. So you could convert the 10 kilograms into 10,000 grams, and then you would say, well, the 10,000 is bigger than the 900, and so the 10 kilograms must be bigger. Notice how you've had to actually make the conversion to have them both be in the same units, whether that be in grams or kilograms, it doesn't matter, but you have to convert them into the same units before you can compare the figures. You can't just say the 900 is bigger than the 10, and so the 900 grams is bigger than the 10 kilograms. And that's the exact same concept that we're applying over here, right? Even though the 150 looks bigger than the 100, we need to convert them into the same unit to be able to make that true comparison, right? And if it makes it a bit easier, I've subscripted both of these um, units. So on the left-hand side, I've put a subscript of 0 next to the pound sign, and on the right-hand side, I've put a subscript of 1 on the pound sign. And that's just to show that these are two different units. They're not just referring to pounds, they're referring to pounds at different points in time. And so you can't make a like for like comparison between them. Okay. So why exactly can't you make a comparison between them? They're both units of money at the end of the day. So why is it that you can't make a comparison between them, even though they're at two different points in time? And again, I think that's best explained through an example. Let's say in advance, before you have to make the choice of the 100 now or the 150 in 1 year's time, you know that someone is gonna appear in the middle of the year, right? And they're gonna offer to double your money, right? They're just gonna offer to double any money that you have for free, and that is the opportunity that you have. Well, in that case, now it's better to take the 100 over the 150. Because if you have the 100, which you take right now, and you go through the year, and this person who doubles your money appears, he's going to double your 100 into 200. And then if you keep that through to the end of the year, you have a £200 note, or sorry, a £200 currency instead of the £150 currency, right? So in that case, choosing the 100 was the better outcome for you. And that shows something important. It's that time, that 1 year gap, gives you opportunities. And so if you chose the 100, you can exploit these opportunities that you might not have been able to had you taken the 150 in 1 year's time. Okay, and this opportunity that I'm talking about over here, it can be anything that you want it to be. Okay, so if we're talking about comparing like for like, you need to account for the value of that opportunity that having this 100 right now brings you. So if you want to make a like for like comparison, you're going to be comparing the 150 to the 100 plus the opportunity. Now, both of these are in these same units. They both occur in 1 year's time. And so you can make a comparison between them. Previously, you were comparing grams with kilograms, but now you're comparing kilograms and kilograms together. So you can look at the actual number and say that one is better than the other. But opportunity over here isn't a monetary amount. It's not a number. So how can you actually compare it with the 150, right? Well, if I were to tell you that opportunity is worth so much, it makes it simple. In this case, let me say that the opportunity is worth £200. Well, then your decision's made. You have the 100, which you started off with, plus the £200 of opportunity, and you're left with £300 in 1 year's time. And that's clearly better than the 150. So in that case, you would prefer to go for the 100 because the 100 paired with the opportunity of £200 is much better than the 150 that you will get in 1 year's time. Similarly, if I told you that the opportunity was worth £10, you would prefer the 150. Because if you take the 100 now and you get the £10 worth of opportunity added onto it, you're left with 110 at the end of the year. And that's less than the 150. So in that case, you would prefer the 150 in 1 year's time rather than the 100 now. And what this shows you is that there's no one answer for any situation. It depends on the opportunity that you have, and this opportunity can vary from person to person. You might have the opportunity to make £200 with your £100, for instance, whereas I might only have the opportunity to make £10 with my £100. So in that case, you would choose to take the £100 because you can make £200 out of it and end up with 300, whereas I would choose the 150 because I know that if I went for the 100, I would only get 10 more in terms of opportunity, and so I'd actually end up worse off than picking out the 150 in 1 year's time. Now, we've been talking about opportunity in terms of absolute money. That's £200 or £10 or £50. But typically, it's referred to in the form of returns, or it's referred to in the form of an investment, right? So let's say that your opportunity now is not £10 or £200, but rather it is the opportunity to invest whatever money you have at a 10% rate of return, right? And this is a risk-free rate of return. So you can put this, let's say, into a bank. They will give you 10% guaranteed, no risk on your initial capital at the end of the year. All right. And in this case, again, what will you prefer? Would you prefer the £100 right now or the 150 in 1 year's time? Well, if you took the £100 right now, you can invest it in this bank at a 10% rate of return, and you will end up with 100 plus 10% of 100 for that return. You'll end up with £110. And so since the 150 is better than the 110, you will prefer the 150 in 1 year's time instead of the 100 now, right? And similarly, if the opportunity now was to invest at a 60% rate of return, so it's no longer a 10% rate of return, it's a 60% rate of return. In that case, if you take the 100 now, you can invest it in the bank, which is offering an amazing 60% rate of return risk-free. You'll end up with 100 plus 60% of 100, which is 160. And that 160 is better than the 150 that you would have been offered under option 2, right? And in that case, you would prefer to pick the 100 now instead of the 150 in 1 year's time, because you know that you can take this 100 now, invest it at a 60% rate of return, end up with 160 in 1 year's time, and that is better than the 150 in 1 year's time that you would have got. So how exactly did we calculate this? Let's see if we can formalize it, standardize it a bit. So let's say now that our opportunity is to invest at a 20% rate of return. Well, what we did was we started off with 100, which was our initial value, right? And then we added 20% of that 100 to get to 120. So if I were to simplify this in another step, that would be your 100 multiplied by, in brackets, 1 plus 0.20. And this does need to be in brackets because we want to isolate this calculation first. We want to do this bit first and then multiply it by the 100 afterwards, right? And that 0.20 is simply the 20% in decimal format. So 20% is equivalent to 0.20, right? So all we've done is taken the 100, multiplied it by 1 plus 0.20, and that's given us the 120. And just to simplify that as another step, we've taken the 100, multiplied it by 1.20, and that's given us the 120. So we're calculating the future value of this 100. This is what it is worth right now at 0.0, and we want to calculate its future value at time 1 given a 20% rate of return. And that's what we're calculating over here. We're just calculating the future value. And this future value occurs at time 1. And so we can compare this with the 150 that is also earned at time 1. Again, if we were to do the same thing but with a 50% rate of return, we do the exact same calculations, but we just use a 50% rate of return. So we have the 100 plus the 50% of the 100, which gives us the 150. To simplify that further, we can say that that's equivalent to 100 multiplied by 1 plus 0.50, which again gives us 150. And that is equivalent to 100 multiplied by 1.50, which gives us 150. All of these three steps show the exact same thing. They're just showing it in more condensed of a format, and that's it. So what exactly were we doing here? Like, let's see if we can generalize this in some way, right? Because we were using very specific figures. We were using 100 for your initial value. We were using 20% as your rate of return. And in this case, it happened to give me £120 in the future. But let's see if we can generalize this for any initial value, for any future value, for any rate of return. Okay? So this is what we have. This is our equation, 100 multiplied by 1 plus 0.20, and that gives us 120, right? Now, I'm going to say that future value, and I'm going to label this as FV, is going to be equal to 120. So now I can take this 120 and replace it with FV, okay? And that's all I've done. I've taken that 120 and I've replaced it with FV, right? It's still referring to the 120, and you can see it over here on the right-hand side. FV is equal to 120. So I haven't changed the equation in any way. I've just relabeled it, okay? And now I'm going to do another bit of relabeling as well. This 100 that you see over here, I'm going to call it the present value. And you can see that over here on the right-hand side. Present value, PV, is equal to 100. And then I can do the exact same exercise where I remove that 100 and I replace it with PV. Again, I haven't made any changes to this. I've just substituted one thing for another. So at the end of the day, this still remains the exact same. And the last change that I'm going to make is on the return, and I'm going to call this R, right? And that in this case happens to be 20% or 0.20. And in this case, I'm going to change that 1 plus 0.20, and I'm going to replace that with 1 plus R. And again, R is 0.20 in this case. So I haven't really made any changes. I've just relabeled them. I've taken the numbers and I've replaced them for letters. Now, you might ask why I've chosen to use these very specific letters in my case, and that's purely because of tradition. It's how I've learned things, and it makes sense to me. Using PV to denote present value, using FV to denote future value, and R to represent return makes perfect sense to me, so I'm happy with using that. but you don't have to. If you want to use a different letter to denote these things, by all means, do that. Because like I said, we're not changing anything here. We're just substituting numbers for letters. So it doesn't matter which letter you use, the end result is going to be the same. But now what we have is we have a general equation that we can use. I can put any value for PV in here. I can put any value for R in here, and I can use that to calculate what the future value would be, right? So using this equation over here, right? If I were to tell you, well, the present value is 50, right? So far, we've been looking at 100 as your initial value, but now we're going to try 50. And similarly, the rate of return R is now 5% or 0.05. In the last example, we said that it was 20, right? So we've changed the present value and we've changed the rate of return, right? So we just need to put them into this formula that we have created, right? And use that to calculate the future value, right? So the future value in this case, which we didn't initially know, we can calculate using this equation as 52.50. And that's all we've done. And it's that simple. You've just used that equation, which we have calculated or derived ourselves, and we've found the future value by being able to input the present value and the rate of return. Okay, so this is our generalized equation that we can use to calculate the future value given any present value or rate of return R. But just like any other equation, you can rearrange this, right? And when you do, it gives us something quite interesting. All I've done in this case is taken that first equation and I've divided both sides of this equation by 1 plus R. And when I do that, this cancels out and it leaves me just with PV on the left-hand side. And on the right-hand side, we have FV, which is the future value, divided by 1 plus R. And this is quite interesting because what this means is if I give you the future value and I give you the rate of return R, then you can give me a present value. Because everything that we've been doing so far involved me giving you the present value and me giving you the rate of return R, and then you take the present value, multiply by 1 plus R to get your future value. But what this shows us is that you can work the other way around as well. You can use the future value if I give that to you, and you can use the rate of return R if I give that to you, and use that to calculate an unknown present value. Okay, so just to show you this, we've got this equation that we have found in the previous slide on the top right over here. Okay, and everything that we have been doing so far involved working forwards in time. Right, so this is right now, this is at some point in the future, and what we did was, our rate of return is 60, so we've taken the 100, we've multiplied it by 1 plus R, which is essentially what this calculation is doing, and we've calculated the 160, right? But what this shows is that we can use the future value and divide it by 1 plus R to calculate the present value as well. So if I take this future value of 150, and I divide it by 1 plus R, which is 60% in this case, so it's 150 divided by 1.60, that gives me 93.75. So I'm calculating the present value of this 150. Now, the decision here does not change, right? If I take this 100 and I calculate the future value of that 100, it gives me 160. The 160 is bigger than the 150, which means this is the better option for me. If this is the better option, then that means that picking the 100 initially is the better option because that is what gave me the 160 in the future. So my decision when I'm looking at the future value is to pick the 100 because it is the better outcome for me. If you were to calculate the present value of the 150 instead, so the 150 is to be earned in 1 year's time. If you want to calculate how much that is worth right now at time 0, you can use the present value as well. And that present value gives me 93.75 when I take that 150 and divide it by the 1.60. Now, when you compare this 93.75 to the 100, again, the 100 is better. So you would prefer the 100 over the 150 because the 100 is bigger than the 93.75 present value of the 150. right? So the decision remains the same. You always choose the 100 regardless of which way you choose to do the calculation, right? So you can do it either way, but it gives you the same choice. And that brings us back to our weight example, right? I could have taken this 100 and converted it into kilograms and compared a kilogram figure to a kilogram figure, and I can make a choice based off of that. Or I can take this 100 figure, which is in grams, right, and convert this kilogram figure into a gram figure and compare both of them instead, right? It doesn't matter which way I choose to do my calculation. I can convert them both into kilograms or convert them both into grams, but the decision at the end of the day is the same. One is bigger than the other. Okay. Now, so far, we have only considered payments occurring 1 year into the future, right? So we had in our previous examples said that 150 occurs in 1 year's time. Now let's expand upon this a bit further. Let's say that the 150 occurs in 2 years' time instead. Okay. This problem is identical to the one that we've been looking at. It's not that different, right? And the way to look at that is I can break this problem down into two problems identical to the one that I was just looking at. So in this case, we know how to do present value calculations for 1 year. And so 2 years can just be treated as two 1 year time segments, right? So if I wanted to calculate the present value of this 150, what I can do is I can calculate the present value of this 150 at time 1, right? So moving it back by 1 year, from year 2 to year 1. And we know how to do that. We take that 150 and we divide it by 1 plus r. R in this case is 10%. And that gives us 136.36, right? And then we just repeat it again because this is a value at year 1 and we want to calculate its value at year 0, right? So this is again 1 year ahead of year 0, so we need to repeat exactly what we have done. We take this value, which is 136.36, which is to be received in 1 year's time, and we divide it by 1.10, which is 1 plus r, and that gives us 123.97. This 123.97 is bigger than the 100, so we prefer this option here. And how did we get this option? Well, we got this option by choosing the 150 in 2 years' time and calculating the present value of it. So based off of this calculation, the 150 in 2 years' time is better than the 100 now, given a 10% rate of return. So the shorthand way of doing this is by taking that 150, and essentially what we did in the previous slide was we divided it by 1.1, and we took the result of it, and that was 136.36. And then we took that 136.36, which is denominated in the numerator over here within the brackets, and we divided it by 1.10 again. And that gave us the 123.97, which we compared against the 100, and then we said, oh, this is bigger, and so the 150 is the better choice. Another way to denote this is just 150 divided by 1.10 squared. It's just the denominator that is being squared, and that gives us the exact same result, 123.97. Right? Now, see if you can spot the pattern. In this case, we've changed the question again. This 150 isn't occurring in 2 years' time anymore, it's occurring in 3 years' time. And in this case, what you would do is you would take the 150 and you would divide it by 1.10 to the power of 3 to calculate 112.70. Again, this is higher than the 100, and so the 150 is what you would prefer in this case. Again, another example, if it was occurring in 10 years' time, you would do the calculation of 150 divided by 1.10 to the power of 10, which gives me 57.83. In this case, the 100 is bigger than the 57.83, so you prefer the 100 now instead of the 150 in 10 years' time. And you don't have to take my word for it. You can go through the calculations that we've done so far, and you can repeat it for a 10-year 150 and see if you get 57.83 as well. But if you've noticed the pattern, it is The number of years that we're looking at, that's what appears here on the numerator. That's what appears here in the power. In this case, we were looking at 10 years, and so we put 10 over here. In this case, we were looking at 3 years, and that's why we put 3 over here, right? So if you wanted to generalize this for multiple years, we can generate another formula for this. What we have found out so far, this equation here only applies to a single year. It only applies when you're discounting something that's happening 1 year ahead. So the 150 that was occurring 1 year ahead. But if you wanted to generalize this for multiple years, right, something that could occur 2 years ahead, 3 years ahead, or 10 years ahead, then we need to change this up slightly. And the exact same pattern that we spotted last time was whatever the year was, that's what the power that we raised it to was. That's what the power that we raised the denominator to was. So in this case, I've just replaced that with an n. This n can be any number of years. It can be 1 year, it can be 2 years, it can be 3 years, or 10 years, or anything that you want. But what this gives us is a general formula that we can use to discount any cash flow. We can convert any present value into a future value or any future value into a present value, both given a rate of return R. And if we're given the number of years as well, then we can do that calculation. And that brings us to the end of this video where we've covered time value of money. And we'll see later on in subsequent videos how this is a very critical concept in finance. It might seem like a straightforward and a simple concept, and it is once you get your head around it. But it's quite flexible in the number of different places that you can apply it to. And it is used in quite a few different places as well. And we will look at this in subsequent videos as well. Thank you, everyone.